Welcome to an exciting bonus edition of the Uptime Wind Energy Podcast, where we explore the latest innovations in the wind industry. I'm your host, Alan Hall, along with my co-host, Joel Saxum. And today we have a game-changing topic that's sure to spark your interest. As we know, the wind industry is relentlessly striving for greater efficiency and cost effectiveness. And one of the key areas that is undergoing significant changes is the bolted connections. Today, we have the pleasure of hosting Pete Andrews, Managing Director at EchoBolt, a UK-based company that is revolutionizing bolt inspection. Instead of traditional retensioning methods, EchoBolt has introduced a faster and more accurate approach that has the potential to transform the way the wind industry thinks about bolts. So join us as we delve deeper into the complexities of bolted connections in wind and discover the cutting-edge technology that EchoBolt is bringing to the table. Pete, welcome to the program.
Hi, Alan. Thank you very much. It's good to be here.
So one of the concerns out in the industry at the moment is what is happening with all these bolted connections and some of the problems we're seeing in bolted connections. In particular, in the United States, we're seeing a lot of issues with blade bolts and foundation bolts. Are you seeing some of the same things over in Europe and the UK?
Yeah, I think so. I think it's really a story of two halves with bolted connections on wind turbines. Either your bolts are behaving in a static manner and are fine, and you can almost leave them alone for the life of the asset, or you have persistent problems. And it's exactly the same story for us. It's blade-to-blade bearing connections, sometimes foundations where you get degradation of concrete, etc. And so we're really helping customers focus in on those problem joints and hopefully engineer ways and investigate and help them solve the issues that they're having.
A question for you, Pete. So when we talk bolted connections, right, on the wind turbine, we're mainly talking tower to foundation. We're talking tower section to tower section, and usually tower to bolts. Or I mean, tower to blades. Sorry, tower to bolts is that's going to happen. But to the blades. So, do you run it when you talk about it's a dichotomy, right? It's either you're having problems or you're just beautiful and everything chugs along and it's business as usual. When you guys are out there, and you don't have to name any because we don't want to drag anybody through the mud too bad. But are there certain kind of so we deal with blades, and there's certain models of blades that we know, if someone calls me and says they have a lightning issue, ooh, what kind of blades you got? And we kind of know. Or, hey, we're having, root cracks. What kind of blades you got? Oh, yeah, we know. So is there certain tower section models and foundation designs or blade, root sections that you guys know, if someone calls and says, hey, we've got this. Oh, yeah, we've seen that problem before. EchoBolt to the rescue. We've got a solution for that.
It's often the case that when you've got issues in the operations phase, the root cause stems from the construction and installation. And very often it's when joints have been torqued in a relatively uncontrolled manner that the bolt-to-bolt variability and the initial preload wasn't where the design intended. The kind of rule of bolted connections is whatever you think your tension or preload is, you've got less. And that's just the way it is, particularly if you've torqued the joint. So where we've got long, thin blade studs that have been torque tightened instead of stretch tensioned, often they haven't achieved the preload that would have been desirable during installation. And the same is true with foundations. So early on in the offshore industry in Europe, a lot of the monopile to transition piece foundation connections were torqued, and they're very large M72 bolts. And we've seen multiple times that those joints haven't achieved the preload and have therefore been problematic in the operational phase. So I think if you came to me and said, I'm having issues with my with a particular connection, the first thing would be, what are your installation QA records? How was it installed? And probably, let's say 90% of the time, that's where your issue lies.
Now I'm thinking I'm putting on my construction hat. So if I was on a site and I had 100 towers and I had an issue with one of them right away, and I looked at QA records, then I would say okay, give me the QA records from that team or that team lead who was working on these, and let's go check all of those within this wind farm, because that might be somewhere where you could, as a armchair root cause analysis study, say like, all right, if we're having some issues with this one, we may be having issues with other ones that are done by the same group of people.
It's certainly the case that you could end up with uncalibrated equipment. So you get an incorrect hydraulic pressure, for example, or corners can be cut where you have multi-stage processes. You're supposed to say torque to 50%, 75%, 100%, and people just bypass that. But the main thing I'd say is, if you're thinking about when you're installing turbines, do a percentage where you prove the preload from your installation process. Prove to yourself that the process you're following will deliver the correct output. And it only need be, on a large site, let's say 100 turbines, 5 or 10%, you just check and verify. But I'd say it's more the procedure more often than an individual team or piece of equipment that could be improved.
So bolts stretch when they're tightened. That's the whole point, right? Is that they go through a process of the 50%, 75%, 100% on tensioning, because the bolts actually physically stretch. And that's where EchoBolt steps in. Because, and I want you to walk through your technology here, but essentially you're relying on the fact that as bolts are tensioned, they get longer. So can you walk us through what EchoBolt does with that knowledge?
Yeah, so perhaps if I just take a step back to say, what does the industry currently do in order to maintain the integrity of these bolted joints? And it's typically a check tightening approach. So technicians would go out and maybe retighten 10% of the bolts on each turbine each year, or 100% every 5 years, and see effectively if the nut moves. If it doesn't, the bolt's deemed okay. There are a couple of issues with that approach. First off is it takes a long time, and it's a lot of heavy hydraulic equipment, a lot of manual handling, a lot of technician time and turbine downtime. So it costs a lot of money. Our sort of rule of thumb is that in Europe, it probably costs you something in the region of €1 million per installed gigawatt per year just to go and routinely tighten bolts. So it's a really significant cost. It's probably the single biggest maintenance activity that's done in wind. So obviously that's a problem. The second issue is you aren't proving the load in the bolt. You're just validating if the nut if the nut turns. And if the nut's seized, then it's not going to turn, whether or not the bolt is tight. And so we've seen operators who have been operating wind turbines tightening the bolts in this way, thinking everything's fine, but actually the nut has just corroded to the bolt and they don't have the load that they had. So there are some really fundamental flaws in what we're doing as a status quo. And you're absolutely right, Alan. So what we do at EchoBolt is look to validate the stretch or the elongation of the bolt. So we try and prove that the bolt has got the load in it directly rather than inferred through a amount of turn. And we primarily use ultrasonic measurement techniques. So it's really an extension of a non-destructive testing method, where traditionally you might use it for thickness checking on a boiler plate. It's that sort of sending out a pulse of energy, measuring the time for it to return to measure the thickness of a material is what we're using on bolts, and it can be extremely accurate. So we can sort of we can measure to, let's say, half the width of a hair in terms of our level of accuracy. The bolts on wind turbines can be very significant. So the bolts can be 0.5 meter long and will stretch by over a millimeter. So we can be very accurate in determining whether or not bolts have lost load or and are operating at the load they should be. The major advantage of this is that you can monitor a sample of the site. You don't have to go and measure every single bolt. If you can prove that 10 or 15% of your turbines are healthy with a good margin, then that finding is, you can extrapolate that finding across the whole park. So rather than revisiting every turbine every year to go and do 10% of the bolts, you can really be far more targeted and treat this as a condition-based inspection technique, and only widen the sample if you start seeing issues.
So instead of basically pulling on bolts to tension them to usually 90% is the number I hear quite a bit, you can actually just put one of your sensors on there and say, yes, this bolt is in tension because we know how long it is.
Yeah, that's exactly right. So it's just a small handheld device, very quick to deploy. We sort of probably in the order of 10 seconds per bolt to do a measurement. So you're carrying around something that almost fits in your pocket rather than trying to lift lots of equipment, hydraulic hoses, pumps, tensioners, etc., all over the turbine. So it's a really really efficient way of achieving a good inspection result.
Yeah, man, I'm thinking especially for guys going up tower. Like it's easy to back a truck up to the foundation of the turbine and check some bolts, but when you got to start going up tower and you're hauling hydraulic hoses, equipment, kits, pumps, all this stuff up, that sucks. So if you can go up there with just a little handheld device and strapped on with a nice carabiner clip, so you're not dropping, you're avoiding the dropped object syndrome. Like, man, that's great. That's a game changer for the industry.
Particularly when you start to get into looking at blade bolts and you need to access the hub, and you're kind of often on the smaller onshore machines, it might be an external access. So you're over the nose cone trying to get in. Each time you need to turn the shaft, pitch the blades, you're in and out and in and out. It can be a very laborious process, and sort of anything that you can do to streamline that really pays dividends in terms of the turbine downtime. So
you're saving about 90% of the time, at least 90% of the time, if you're checking blade bolts, tower bolts. That has to be a relatively fast process compared to retensioning all those bolts and like Joel was saying, all the equipment hauled up and down the tower. That's a huge financial savings.
Yeah, I mean it's a much quicker inspection, and in general, we're inspecting far fewer turbines. So you're absolutely right. We would expect to take the turbine off for less than 10% of the time of your kind of status quo, and it's fewer technician days. So, it can be a really substantial saving for operators of wind assets.
So walk us through what this EchoBolt solution looks like. If I'm a customer and I'm in Oklahoma, I have 100 turbines out there, and I know it's been a couple of years. I know I have some bolting issues. I call you. What does that look like? Walk me through that process.
So I suppose the first thing is to understand whether or not you are having problems or you suspect that you have a problem joint. If the answer is no, then you're into sort of, okay, what can we do to replace our scheduled retightening activity? And the EchoBolt offering there is either we come and deliver a service for you, we send our technicians to inspect your site, or we train up your team. Training course would typically be 2 days, and we could lease or sell you the kit. And what we would do is then put in place with you a kind of recommendation how many turbines we should inspect. So let's say you've got 100 turbines, we're going to inspect 15% and do 15. We typically aim to complete a turbine a day. So for most onshore turbines, it's probably 2 technicians can inspect all the bolts in a turbine in a day. It's probably 1 in the hub, one doing everything else. So we would then aim for your 100 turbine site to have inspected all the bolts in 15 turbines in 15 days and set a baseline that we can monitor from going forward. And then year on year, inspect those same 15 turbines. As I said at the start, for the majority of joints in wind, they're really stable. They aren't losing load. And you'll find very quickly that you build up a trend and can be confident that the preload is maintained and you're not going to have any problems. The flip side is if you do have a problem connection, like a blade to blade bearing where you're finding failed studs and you're having to periodically go in and replace and repair damage, etc. What we would do there is something a bit more investigative. So we would go with you and look at what's the existing preload, what's the maximum load we could put in the bolt safely, what's your installation method, can we improve your tightening process to add preload to the joint safely? Because the majority of failures are fatigue failures where you don't have enough load, the connection is opening, and the bolt's seeing far greater dynamic load than it's designed for, so it fails prematurely. So the kind of number one remedy is to try and raise the preload in the joint to try and guard against that fatigue failure. So it's slightly different if you have a problem that you're trying to engineer out. We end up in a bit more of an investigative mode. But for, let's say, 95% of the connections out there, we would just replace your annual, I'm going to retighten 1 in every 10 bolts, to we'll ultrasonically inspect all the bolts on 10% of the site.
One of the use cases I'm seeing here, Pete, is that we're starting to see a lot of acquisitions, mergers and acquisitions in the US, where company XYZ is buying company AB's assets. And it's like every time we turn around, it's like, oh, so-and-so sold, and some of them are huge, right? So-and-so sold $4 billion in assets. Oh, this wind farm was bought by these people. This wind farm was bought by these people. So when you have this juggle of record keeping and who's responsible in O&M activities, right? Because it might be commissioning day, installation contractor hands over to OEM, even though an asset owner owns it. So OEM might maintain it for 5 years or 10 years or whatever, but then that might pass to the asset owner now doing the O&M activities themselves. And then 2 years after that, they might sell the whole thing to someone else. So now there's like the chain of custody is 3-4 different companies long that may not have involved in the project for 10 years. So as a asset, as the purchaser of that asset, it's like, how do you trust the record keeping and all these things that come in? So it might be really smart for someone that's acquiring a wind farm to say, you know what, let's get EchoBolt in here. Let's check all these to make sure that we are, we're running this risk free, or, controlling our risk as good as we can, because you just never know what could happen, because you can look through the records all you want, but you might find you're going to find gaps. I know that because we're requesting records all the time for cases, and you just don't get stuff. So I think that that's a huge use case that anybody out there buying a wind farm should look into this. In my mind, that's the smart thing to do, right? It's like going over a car when you first buy a used car and checking all the lug nuts.
You're absolutely right that there are some sort of high value or high benefit moments of time in an asset's life. So there's obviously installation. We've spoken about that. Using this as an installation QA tool can be really valuable. There's the period where your OEM is probably servicing your turbine and you've got a warranty. So before your warranty ends is another high value time. Make sure you kind of can prove that you don't have serial defects, etc., out there in your fleet. Any of those changes in ownership, as you said. But then the other one that we're increasingly seeing in Europe is life extension. So we're getting to year 20, year 25. Operators are thinking, how do I give myself confidence that these assets are safe to continue to operate? And one of the ways we can do that is help them in the few years prior to build up a trend to say, okay, we know these joints have been operating in a good envelope and that they're stable. And so the design conservatism that was built in on day one, we are happy that can be reduced. And it's, a similar way to how people might do structural fatigue monitoring over time to try and prove that they can extend an asset's life. We can do the same thing with the bolts. And so, there are these key interventions that you can make at strategic points in the life of the site. And what I'd always say is that a few years trend is so much more valuable than a single data point. So you can get a data point to say, yes, we know the load in this bolt, but if you know that it's going down versus stable or going up, which is unlikely, that's a more useful piece of information. So you always want to think 2 or 3 years out from these key moments and sort of plan how you're going to address them.
Pete, one of the things we like to talk about is the customer experience. And I imagine the customer experience with EchoBolt has been really good because you're actually saving them a bunch of time and money, but also giving them peace of mind.
Yeah, it's been an interesting journey for us because obviously we're quite a new company. I guess there is some nervousness about trialing a new technology with a relatively unknown entity. So I suppose our customer journey has often been to pilot the technology at a small scale. But I think almost every pilot we've done has led to a wider site-wide or fleet-wide deployment. So it's sort of really good feedback for us that customers are coming back. So that's the first thing. But yeah, the sort of typical interaction, as I sort of said, it's one of two things. We're either investigating a problem and then it's a bit organic. We're looking at different solutions and different technologies and sort of coming together to find a way forward. Or we're just doing a direct replacement of a check tightening philosophy. I think in that latter case, we've been able to show customers year on year, bolt preload isn't changing. They've been able to make decisions to drop big bolt retightening campaigns. So say probably the first customer we did was an offshore foundation connection. They've got over 5 years of ultrasonic measurement data. But in year 5, they would have had to do 100% retighten of all of the joints. So it's over 100 turbines. These are confined space entry, big tensioners. The tensioner tool weighs over 100 kilos. So it's a huge effort. It would have been millions of euros of cost to do 100% of those bolts retightening. But with 5 years of data, we were able to show there's been no change in preload and there's nothing to gain by retightening those bolts. And they've eliminated that step and saved that cost. And that's sort of the story we're seeing increasingly as we do different joints, different areas of the turbine. In the vast majority of cases, you can save over 90% of that €1,000,000 per gigawatt that you're currently spending. So hopefully, in general, our customers are quite pleased to have engaged us.
Yeah, I bet they are really pleased because it's all about controlling costs right now and making sure your turbines are operating at peak efficiency. The EchoBolt story is really amazing, Pete. So, Pete, how do people contact you? How do they reach out to EchoBolt?
Yes, there's a few ways. We're active on LinkedIn, and you can find me direct and my colleagues. Probably the simplest way is our website, which is www.echobolt.co.uk. And from the website, you can get some case studies, see what we're about, and there's links to get in touch on there. But I'd just say if your audience is interested in the topic, would like to learn more, or like to understand what's involved in doing this sort of inspection, please reach out, and we're always happy to speak to people.
Yeah, Pete, it's been great having you on the podcast. I've wanted to talk to you and learn about EchoBolt for at least the last year, so I'm finally glad to have you on the podcast. So, Pete, thanks so much for being on. We look forward to hearing more from EchoBolt.
Thanks, Alan. Thanks, Joel. It's good meeting you both.